Good morning, everyone. I'm going to try to make a quick walkthrough of assignment number 15. We'll go pretty fast here. So we have this circuit here. It's got two bulbs, bulb A, which is a 10 ohm bulb B, which is a 5 ohm bulb, and we know that we have a 10-volt battery pack. Remember, voltage is the pressure drop. So I'm actually going to go ahead and start color coding this. But in this situation, red to blue just means that we have a pressure drop of 10 volts. All right. Now, in between bulb A and bulb B, we know there's going to be a pressure drop. Now, I could just make it yellow because I know it'll be somewhere in between red and blue. But see how this is a big, a relatively big resistance? Larger resistances mean we get a bigger drop. So instead of a two-step drop like red to yellow, I think this could be even like a three-step drop like red to green. This is a smaller resistance, so it'll get a smaller drop. So this will only be like a one-step or something. So that's my guess. Now, ultimately, this color coding doesn't mean a ton right now. It's just going to help me think about it for the future because we are going to be using our new equation. So remember, the equation that we'll end up using for this is that the voltage is equal to the total current times the resistance. And that's true for the whole circuit, but that's even true for little parts of the circuit. So let's go through and start working through this. What is the overall resistance of the circuit? Well, let's follow the path and see what we see. So I have current that goes through the red part, the high pressure, has to go through bulb A, that's 10 ohms. So all the current has to go through 10 ohms. And then all the current has to go through 5 ohms. So all the current has to go through both the 10 ohm and the 5 ohm. I believe that'll make this a 15 ohm circuit altogether. So all of my current has to go through that, and it has 10 volts pushing it. So question number 2, what is the overall current flow? Well, I know that the amount of voltage you have pushing will be equal to the amount of current you have times the resistance. That's how we defined resistance, right? Resistance is given some amount of current that you want to flow, how much voltage do you need? That's what resistance is. So if I'm just going to go ahead and plug stuff in. If we have a 10-volt circuit, and I want to know how much current we have, I know that this will end up being 15 ohms. I'm going to solve this for the amount of current. The amount of current that we end up getting then is 10 over 15, and then that's volts over ohms, but volts over ohms is just the same thing as amps. So 10 over 15 reduces down to 2/3 of an amp. I personally would prefer it as a decimal. Rather than a fraction, but I would accept either of these. So we're going to get 2/3 of an amp running through this circuit. So if we're going to go ahead and draw our little arrow tails, right? These arrow tails specifically represent 0.67 amps of current. But that means we get the same 2/3 of an amp here, the same 2/3 of an amp here. So question number 3, what is the voltage drop across bulb A? So let's look here. This equation that we have still works for just little parts of the circuit as well. So this little part of the circuit we know has 0.67 amps running through it, and we know has a resistance of 10 ohms. So let's plug all that in. So what is the voltage drop across bulb A? Well, voltage is equal to current times resistance. Voltage then will be equal to our 0.67 amps times our resistance of 10 ohms. That ends up giving me a voltage drop of 6.67 volts. Sorry, 6.7 volts, depending on how you rounded it and stuff up here. So I'm pretty sure that first bulb will be a 6.7 volt drop. And notice that matches what we thought. A perfectly even split here would be a 5 volt drop because it's 10 volts overall. Well, this is a little bit more than that. This is a little bit more than halfway of the voltage drop. So what is the voltage drop across bulb B? Well, there's two different ways we could do this. We know that the overall voltage drop is 10. We just did 6.7. So the rest must be 3.3 volts. But we could even check that here by using our equation with this 5 ohms. So in the 5 ohms, we know that the voltage drop will be equal to the current times the resistance, which ends up being 3.3 volts. Same answer either way. So this equation here works either way. It works for the whole circuit, but it also works for the individual parts of the circuit. So please do let me know if you have any questions. This is our last target. And once you get this math down, I think it's one that you can really handle. And I really like it because it puts numbers to all the things that we were talking about all year. All right, everyone, let me know if you have any questions. Have a nice day.